Okay, so we're on a roll, and let's keep going because now that it's fresh in our head, we might can understand the next group or the next family group a little bit better when it concerns lipids. And this is something called phospholipids and sphingolipids. Sphingo is always fun to say. Okay, so phospholipids. I am probably looking for a phosphate group here, so that doesn't really surprise me. I probably will see a phosphorus included in this compound. And then the sphingolipids. Well, the sphingolipids are very similar, and we'll take a look at those as well. So we can actually term these a little more properly if we want. A phospholipid is also called a phospho, guess what? Acyl, because we saw acyl before in triacylglycerol, so why not use it here? Phosphoacyl, and it's phosphoacylglycerol. So very, very similar in structure to our previous family of triacylglycerols. So we will see a 3-carbon chain, 1, 2, 3, and there's a hydrogen here and a hydrogen there and 2 hydrogens here. And off of each one of these carbons, this is kind of coming from my glycerol portion, well, I tend to see more carbonyl groups. So OC double bond OR, OC double bond OR2. However, at least one of these spots has to be reserved for my phospho group. So instead of a C double bond O in one of them, it's traditionally a phosphorus. So a phosphorus with a double bond O on it, and then there's another oxygen here, and then it brings to the table an OH group as well. So there's your PO4. All right, so this phosphorus group classifies this molecule, this particular type of lipid, as a phospholipid. Now, there's a couple of terms that we can use to describe it. Phospholipid is one, phosphoacylglycerol is another, phosphoglyceride is another, but this is basically referring to the same thing. It's just calling it something with 4 or 5 different names just to probably try to confuse you. So if I wanted to, I could come over here to the side and add on another name if I wanted of phosphoglyceride. So PHOSPHO, there's my phospho, and the term glyceride can be used to describe this molecule. Phosphoglycerides, phosphoacylglycerols, phospholipids, if take a look at this group down here below, notice that this is an OH group and this has a tendency to become acidic. So because of that, this forms what we call a phosphatidic acid. So there's something else that I can call this structure, and we can call it a phosphatidic acid. And phosphatidic, I see the IC ending. That kind of relates to, in a way, the acid nomenclature back in general chemistry. I see the word phosphorus, so I know a phosphorus is involved. And I see the word acid, so I know something's going to be a hydrogen donor. So phosphatidic acids are the simplest phosphoacylglycerols. However, they're only present in very small amounts. Where are these phospholipids traditionally found? Well, these phospholipids are traditionally found in cell membranes. And we'll expand on that a little bit later on. But phosphatidic acids, they have very low concentrations. So we see them, but they are not the major dominant player. But they are the most common, the simplest at least. They're simplest, and let me not say the most common, but they are the simplest phospholipids that are out there that we find in cell membranes. So the most common type of phosphoacylglycerols have a second phosphate ester linkage. So basically what that means is that we take this phosphatidic acid name, or this structure, and we just replicate it. So let me draw another version of a phosphatidic acid down here. So we'll do CH2, CH, CH2, and then off of this we find a C double bond OR1 and a C double bond OR2, and then this was an OP double bond O, an O, and an OH. So what we traditionally find in cell membranes, and really the most of, phosphatidic acid, yeah, that's okay, but we tend to see the acid portion removed. This is acidic, so it's not uncommon to see this off of that functional group, and we see something else on it instead. And this can be anything it wants to be, preferably though an ester linkage. So some type of PO double bond O. This is kind of an ester, right? That's what we would call an ester if that was a carbon instead of a phosphorus. And I'm just going to put an R group there. That can be anything it wants to be. It can be a protonated amine group. It can be an alkyl group. It can be anything, really. But the alcohols most commonly used to form the second ester groups are ethanolamines, cholines, and serines. So yes, we get to see an amino acid being thrown into the lipid family. So let me say that again. Most of the time this R group is going to come from something that we call ethanolamine, or it will come from serine, amino acid, or it will come from choline. So either one of these is traditionally commonly used to go there. So there's proper terms that we use to call these: a phosphatidyl ethanolamine, a phosphatidyl choline, a phosphatidyl serine. Ethanolamine, what is that group? Well, ethanolamine is this oxygen that's hanging off of the phosphorus, and then ethyl, CH2, CH2, and then the word amine, and this is an NH3 that is protonated. If I take a look at choline, what's choline functional group? Well, it's that oxygen that's there off of the phosphorus, right? So let me do this number here. And then off of this is a CH2, just like ethanolamine. And then we get this nitrogen. But instead of an NH3+, this is going to be a tertiary, and then or quaternary, and then we see a positive charge that's there. And that's the structure for choline. So basically, serine I'm not going to draw. You already know the structure for serine. That is your OCH2, CHCOO with an NH3 that's hanging off. So it's the entire amino acid, really, in a way, that gets attached to that group. So ethanolamine, choline, and serine are the three of the most common. These have other terms that we use to describe them. Our phosphatidyl ethanolamines are typically called cephalins. So let me go ahead and write that out here. It's going to be long, so bear with me. Have some patience. Phospha, right? And then we look at TI, DYL, ETHA, or ETHANOL, AMINE, phosphatidyl ethanolamine, and these are shortened to a term called cephalins. So when we talk about cephalins, we're talking about a fatty acid that's a phospholipid, that on one of these carbons I have a phosphate group with an OR that comes along with it. All right, so let's take a look at some of the others that we've got here as well. So another one that we see with a common name is our phosphatidyl, just like before, tidyl, Tidyl, choline. So my choline structure is down here at the bottom, and if that group is involved, we typically call these lecithins. Lecithin, lecithins. So we have these cephalins and we have the lecithins. The lecithins are added to foods, and you will commonly find these in things like mayonnaise. And the purpose of these lecithins are to prevent separation. Nobody wants to buy mayonnaise that has separated in the jar. So we add these types of functional groups into that food product so that way they look very attractive on the shelf. If you homemade mayonnaise, well, over a course of time you would traditionally see these begin to separate up a little bit, but these things are added to products so that way they do not separate on you. So that's just one of the many things that lecithins are added to. Very, very common. You eat them every day. And as far as we know, they are safe for human consumption. The FDA has not said anything otherwise. So it prevents the water part and the fat part of these products from separating. It keeps them together nice and jellied. So have fun eating your lecithins, which are your phospholipids, which are your phosphatidylcholines.